it's my pleasure to have you all here. And I guess because you are here, you're probably some of the developers that like static type systems. So who of you likes static type systems? Can you raise your hands? Okay, who of you don't like? Okay, so those of you who don't like static type systems, we have another talk by Mark tomorrow where he talks about why static types are cool, and I guess you should be converted there. We here assume that at least some developers like static type systems, and we actually also fall into that crowd. So my name is Annette Bieniusa. I'm here together with Albert Schimpf. We are from the Rheinland-Pfälzische Universität Kaiserslautern-Landau, which is a university in southwest Germany, and together with our collaborator Stefan Wehr from Offenburg, who can't be here today, unfortunately, we are looking into getting types with static type checking into Erlang. Apparently, we and you are not the only ones that like and prefer to have statically typed languages. And Erlang, even though it has a strong dynamic type system, is actually has a long-standing history of people who tried to get static types developed for Erlang. What we prepared here is an overview. And as you can see, that already, short after open sourcing Erlang, making it available, first successes and so on. The first bunch of people, Malo and Phil Wadler, sat down and tried to come up with a type system. It's been one of the things that actually made people aware that Erlang is not so easy to type check, because what they proposed was not very successful, and this is what we annotated here in blue. So you see a few more attempts for getting types in. There have been attempts for adding session types to type message passing and type communication between different processes. A lot of theoretical, solid work being done. However, it never really materialized into any practically widely used tool, as we believe. Similarly, the work on ETC more recently that featured some type inference, partial evaluation, ADTs, and so on in the context of Erlang was an academic project. Didn't really make it into any tool that is being maintained or so. Similarly, our prior work on bidirectional typing was an attempt, but a not very successful one. The WhatsApp RLT system also was a very interesting approach of getting things done, actually, but also discontinued. What was successful and continues to be very successful and great was the approach that Dialyzer took. Even though Dialyzer is not a type checker, it features success typing and also helped to get type specs into Erlang. Erlang has a type specification language that is part of the language standard, and that's something that is both good and bad. So in contrast to what Guillaume showed today or this morning about designing a type system for Elixir, they are both good and bad off because they have more freedom to decide things. We are kind of stuck with type specifications, and Erlang code has types. What we want to achieve is actually being backwards compatible and supporting what is already in there. And this makes it simple in the sense that we don't need to make very difficult decisions of what the types should look like. We have them, right? We have to deal with them. But this also means that all the complexity that the type system and the type language and the type annotations that we currently have, that we need to support them somehow. So this makes it a bit challenging. There are a few more projects that are here in yellow, and these are the ones that are currently out there, being developed, being pushed by people, and having very interesting aspects that make people use them. One is a gradualizer that features a gradual typing system, gradual typing approach for Erlang. Similarly, equalizer, the equalizer team is working on a gradual typing approach, and we here, in parallel with the Elixir approach for adding set-theoretic types, are looking at how to get set-theoretic types into Erlang. Our type system is called etylizer. As you can see, we follow the great tradition of Izer tools. We couldn't come up with something better, I'm afraid. Yeah, and what we will do now is Albert will guide you now through a few examples just to show where the complexity lies, what shortcomings we have found with existing tools, and what we are aiming for.
Okay. So, as you've seen, we have quite a lot of tools, and let's just look at what the tools are capable of right now. As a developer, we implement code and write spec currently as documentation. That's what they were intended for. And let's assume we write this safe division function. It does two things. If it divides by 0, then the return is none. And if the division is not by 0, then it returns a tuple. We use all the possibilities of the type spec. For example, we can do method overloading by specifying multiple specifications for this function, a branch for the special case 0 and the other branch. And what we as a developer want is to not let the type system get into our way. So it should say this doesn't crash, it's a valid function, it fits the specification, okay. So let's check out what the tools are currently doing. Etylizer does not support overlapping domains, and it throws a warning it will be ignored. That's actually good. It doesn't get in our way. Recently, they made in Erlang 26, I think, this the default. It will not complain. That's good. Great. Even though, the other tools, they are more statically oriented. They throw errors at us. It says one line is not reachable, gradualizer, and equalizer has a problem with type refinement currently for this x here. It expects a number, but it got any, so it can't refine the cases for. It can't differentiate between these two clauses, I think. So this is what we want to avoid. Like we both want to avoid having a false positive, and we want to avoid not checking the type. We want to type check this function that it really does what it's supposed to do against the type spec the developer intended. Okay. Let's see the other side, false negatives. False positives was about not getting into the way of the developer. False negatives are about if there's an error, please report this error for me and to not have this be an error while running the code. So we have here a small example of a function. It takes a list and returns a list, any list. And as a developer, I wrote the spec first, or I wrote the function first, or vice versa. And I'm using a local function, a lambda function, which says convert this input integer to a list. So f is supposed to get an integer, and it returns a list. But the specification says something different. The function expects an int, but the specification expects a list. So there's an obvious mismatch, and it will crash if you input an integer. It will crash at this point. We want a type system to detect this. So again, the three tools. Etylizer is actually able to detect this error. Great, that's nice. It didn't get in our way in the previous example. It gets in our way in this example. This time we want it to get in our way. It prevents us from crashing. Gradualizer is not able to detect this, and equalizer is currently also not able to detect this. So they both throw a false negative currently. Just as a disclaimer, they are both very active in development, so it might change at any point in the future. So we hope that these tools get also better over time. Another category of type errors is we can decide whether we want the type checker to throw something or not. So for example, exhaustiveness checking for branches, for case branches, where some developers like it, some developers don't like it, and they would like to have a flag for it. So one example is a rather contrived example for now, because to show that some edge cases are really difficult to type check. If we have a function which returns a function with arity 2 or an atom. And the specification says we have either a function with arity 1 or some atom returning a function with arity 1 or the atom not function. And by looking at this a bit closer, this branch will never be executed. And by doing exhaustiveness checks, we also get the redundancy checks for free. The type checker should or should not, depending on your flag, detect that the line 4 will never be executed. So what do the type checkers currently say? The dialyzer says it's OK. Gradualizer says it's OK, and equalizer also says it's OK. We argue that exhaustiveness checks and redundancy checks for branches are a good thing, and we would like the type checker to show at least a warning that this branch will never be executed. So these were some contrived examples, but our goal, as stated by Annette, is we want full backwards compatibility, and ideally we want to type check the standard library of Erlang to find type errors and to really check if the body of the function is equivalent or does the thing that types says, because currently right now they're used mostly for documentation purposes. This is one such function, a filter map. It does two things. It both filters a map and it maps elements to another. It transforms elements at the same time. And one of the big challenges is to find an expressive type system at the theory level, which can do things like union types or these user-defined types and higher order functions. We have recursive applications. We have exhaustive checks, checking if we missed the case, or we put a case which will never be executed. We have guards, which are executed in a constant time, which will also trigger different behavior of these function clauses. And this was a really big challenge, finding a type system which allows us to both not get into the way of the developers using the type system, and to also capture this expressiveness of the type spec of Erlang, because the type spec is quite powerful. You can express a lot of ideas, and it's almost right at the edge of encoding the semantics of the function into the type spec itself. So what we have done, we've started looking at the 2-3 years ago. We started looking at the current type systems, what's out there in theory. This type system has unions. This type system has only intersections, and we looked at the things Giuseppe Castagna did at the theory level and said, oh, it has intersection types, it has negation, unions, it has recursion, it has higher order functions. Well, let's try it on Erlang, maybe it fits. And not too surprisingly, it fits very well. Well, at the time it was surprising actually for us. So we implemented it and built a prototype and actually type checked this filter map function, which was actually the sort of the measure of will this work in practice for us. And yeah, we based our work on set-theoretic types, and it was quite a success. So what's the status quo right now? We've implemented quite a lot. Also, we have a sponsor, the Erlang Ecosystem Foundation, which we are currently, or it's at the end of the support of the project. And we're in the transition phase from prototype to something that you can really use. There's some things that are already working. The hard things, I think, are mostly working, like recursiveness, tuples, functions, and so on and so forth. There are some things that are theoretically not that interesting, only requires a bit of engineering, like records, bit strings, and user types. And things that are still currently under work to make it nice for the developer. For example, nice error messages. For now, we have only error messages that say, at this line, there's some error. And at some point, we want to have better error messages that says, this line has some error because we expect this, but got this. So error messages are a big topic, not only because it's hard to engineer, but also at the theoretical level with set-theoretic types and this expressive type system. Error messages become quite a big deal. It's like another research topic in itself. As for the efficiency of the solver, the expressiveness comes at a cost. So I've spent quite some time getting the solver to run efficiently, so to type check at all, because of all this complexity it brings with the type system itself. We've implemented some sort of type reference, but that's more of a prototype. Right now, we're focusing on type checking the body against the type spec that the user intended. So, can you try it? Yes, you can. But first, a short disclaimer: what we are capable of and what we are not capable of right now. So we did testing. What we can do right now with our own testing suite and with the gradualizer testing suite. And this was for us to see, are we actually better at solving difficult problems? So the good thing is we have a lot less red failed things. This is something that will get in your way as a developer. We currently have 3, but it will be 0 because we know how to fix them. Other tools like etylizer, they have, for example, false negatives, a lot of false negatives. It's just not powerful enough. Or gradualizer, which might have some issues with the type system itself. We only have, in quotes, the issue of not having implemented things that are used by the developers, like bit strings, records, and maps. Okay, we have maps right now, but it was a big issue until recently. So we are working on getting this yellow bar down, so it will be usable. With that disclaimer, can I try it? Yes, you can also contribute if you want. We are open source. We have an open source license, BSD2, and it's open for you to try. And please do it, because then you can open issues and poke me by saying, please add more documentation to it. So that would be a good motivation to get into the public. Okay, so what's the outlook? Well, of course, we want to type check, but as Guillaume also talked about, we want to have better types. And we can already do that with just the Erlang type spec. We can refine the types by using, for example, overloading of function headers, which already describe better the type of filter map than it did previously, while being more precise. And this will even further facilitate typesys documentation, because each of these function headers describe exactly one branch of the case. Okay. So TLDR, a static non-invasive, backwards compatible expressive type system is coming also to Erlang, or has already come to Erlang. And with that, I want to thank everyone. We're looking for contributors, especially people who tried out, and sponsors. And of course, try the other tools. They're getting improvement. They're really nice. And use etylizer. Thank you.
Thank you so much. So we are getting ready for lunch. The good news about that is that gives us some extra time for some questions, if you're not that hungry yet. So
I have to ask, have you done any performance benchmarks? How it compares to other tools when it comes to speed of, well, analyzing, especially the large code bases?
Yes, this is the biggest issue, getting it to perform well. For example, this filter map type check, it takes 3 minutes right now to type check the filter map, just the function itself. So this is the time I spent most on getting the performance to be correct. It's quite difficult because there's not a lot of resources on it. But we are at the point where we can say this is feasible and it can be done with a bigger code bases. Of course, this is one of our goals, to reach, say, type checking the standard lib of Erlang in acceptable amount of time.
There's one thing to that. So one thing we make sure is that we modularize things, so we can do type checking per module. You could even parallelize stuff and so on, right? So, but we don't go like dialyzer over module boundaries and so on. So this is kind of helpful. However, there is really an inherent problem with set-theoretic types in its complexity, and this is something that won't go necessarily away in the current implementation that the seed-use team is working on. They have an implementation that is very fast in many cases, and they use a lot of heuristics. We are currently putting quite a bit of effort in, especially Albert, mainly Albert, to re-engineer what the heuristics are, because it's hard to document them, right? And yeah, but we are on a good path, I guess.
Thank you.
I think I saw a second hand here before.
First, thanks for a great talk. So I'm wondering, do you have a rough idea when or how much time it can take to actually cover, maybe not the entire Erlang syntax, but big enough subset of it for practical use?
Yes. Let's go back to this one. So the only things that are missing to get most coverage are these three things, and I'm putting effort mostly on the efficiency side, so I'm not really motivated to do these things, even though they are quite quickly to implement for me. So
so quick meaning a couple of
days, days to weeks, yeah. Yeah, the motivation. I need some motivation to work on these.
So if your code does not use records, bit strings, or user types, you're good to go. But this is why we are also hoping to have a few people who are interested in maybe supporting and helping. As we also seen in the Outlook, refining types in a standard library or something like that, this is going to be opinionated, right? We have a lot of types to choose from. We could type everything from any to any, which is probably not what you want, but it's possible, right? So yeah, having feedback from people who want to try and use it would be great. We are here. If you want to try things on our laptops, grab us during or after lunch. We are here also tomorrow, so you'll have your chance. You can also download and just try and see. Maybe it already works for your code base.
We just merged the user level documentation this morning.
This morning, so you're good to go.